Hi everyone. In this video, we are going to talk about the model types and the rate of change. This is from the unit 2 of QR course. In this unit, we cover two models, linear growth model and exponential growth model. So two models. First of all, let's talk about the linear model. This is the general format of linear model. N represent the input variable. Input variable also called independent variable. And Pn is the future value, is called the output variable. And it is also called a dependent variable. So it makes sense, right? Dependent variable output always depends on the input, right? That's why the input is called independent. The output is called dependent. So dependent variable. And P0 is the initial value, and D is called the growth rate. And the graph of linear model will be a straight line. Look at this word, linear, the first four letters. So the graph of the linear model is a straight line. If this growth rate is positive number, you're going to see the line going up from left to the right. Straight line. And the intersection point on y-axis and vertical axis is the initial value. So that's the initial value here. And the growth rate D is given by the slope of this line. And later on in this video, we are going to demonstrate how to calculate the slope of line, which is growth rate in the linear model, using 2 points. But for now, let's focus on the graph. So if you have a declining rate, that's going to be P0 minus a number here times n. Okay, in that case, the line will be going down from left to the right. Still, this intersection point is your initial value, your slope, which is negative number representing the growth rate. This number is going to be a negative number. Okay, now next model we learned is exponential model. And just like in the linear model, n represents the input variable, this is the output variable. Any model has input or output, okay, variables. And P0 is the initial value, and R is growth rate, is a percentage, okay, it's percent. Now, what is a exponential model graph? And no matter this growth rate is positive percentage or negative percentage, positive means really has a growth, and negative means actually declining. But if we have a positive percentage here, you're going to have a smooth curve going up from the left to the right. It goes like this. A smooth curve. And again, this number, regardless of the quantity of this point, is your initial value. In other words, the value of the curve intercept with the vertical axis, that interception point. Interception point is our initial value. And the reason we have a smooth curve is that this percentage is a fixed percent. This is, by the way, this is how you identify whether you have linear model or you have a exponential model. Whenever the growth rate is a fixed amount, you have a linear model. Whenever the growth rate is a fixed percent, you have an exponential model. If this is a declining percentage, and you're going to have smooth curve going down from the left to the right. Something look like this. Okay, this is the initial value again. So in our model, we don't deal with negative input. So that's why you may wonder why does this initial value start from here, right? So initial value here, definition is that when the input is 0, the output value. Input 0 means input is 0 is here, output value. Okay. And this is a graph for a exponential model. It's a smooth curve. It can only go up or can only go down, depending on whether this percentage is positive or negative. But it never changes a direction anywhere in the middle of the curve. It's monotonically going up or monotonically going down. Smooth curve. That's the exponential model graph. Now, you may encounter something that is neither a linear model nor exponential model. That means it's not a straight line, it's not a smooth curve going up or going down in one direction either. So let me give you an example. So if you have something like this, it's a smooth curve, but it's not exponential model because it's going up and then going down. It makes a turn. Exponential model is a smooth curve that can only go in one direction, either up or down. Okay. Now let's look at how to calculate the rate of change, and actually it should be called the average rate of change given 2 points. We're talking about the straight line. Okay. Now, first of all, why do we need 2 points? So suppose these are the 2 points from a line, okay, or not just 2 points. If we try to draw a straight line going through these 2 points, we just get a straight line going through these 2 points. This line is unique. In other words, there's no second different line that can go through the same 2 points. So the indication is that given 2 points, we have enough information to calculate the slope of the line going through the 2 points. No matter you draw the line or not, the line is there. So that's why we only need 2 points to find out the slope of the line going through these 2 points. And we already learned in the lecture video, in the lecture actually, the slope of line is the same as growth rate in our linear model. So I'm going to pick just 2 random points to demonstrate how to calculate the slope. So I get 2, I got say 5, I got -3, and let's say 4. It doesn't matter which one is which. So let's call this the first point, the second point, point 1, point 2. Now the formula to calculate slope, which is called M, is given by y2 minus y1, output minus output. In any point, the coordinates, the way we write is that input always the first number, output always is the second number. So output minus output divided by input minus input. And doesn't matter use the second point value minus the first point value or the other way. So y1 minus y2, x1 minus x2. It doesn't make any difference because no matter you suppose it's P1 and P2, no matter you go from P1 to P2 or from P2 to P1, even though they have different directions, but either way you get the same line. Same line will have same slope, and that is common sense. We just demonstrate to make people feel comfortable. Actually, this is the case. But when we learn something, we better try to make sense out of it. When things make sense, you're going to accept it. You're going to be able to use it with comfort. Okay. So I'm going to demonstrate that. Suppose I'm going to use a P2 minus P1, Y2 minus Y1. Okay. Let's see what I get. 4 minus 5, then x2 minus x1, -3 minus 2. Again, -1 on the top, -5 on the bottom, and the negative divided by negative is positive. So I get a positive 1/5. Now, what if I do from P1 to P2? So I use y1 minus y2, 5 minus 4, and x1 minus x2, 2 minus -3. What do I get? 1/5. Yeah. It's supposed to be the same. No matter which direction you go, that's the same line. Same line will give you same slope. Okay, now let's move on to the next page. Now I copied and pasted from your homework section, this one. Just make sure people understand the question correctly. There's a lot of misunderstanding of the question itself when I grade this part of the homework. So first of all, we are given two columns of data here. The first column is time in minutes. The second column is height in inches. The point 1 has this coordinates 0, 136, 0, 136. And they ask us to calculate the rate of change. Look at the format. Format is the change in height divided by change in time. How do we get change? We do subtraction, get change. So that's why this is going to be our output. Remember the formula to calculate the slope. y2 minus y1, x2 minus x1. This is the output variable minus output, input minus input. They take this height as the output. They put height on the top, okay? So this is output, this is input. That's why they present this number as the first number, this one as second number, horizontally. So this is input, this is output. You can imagine there's a parenthesis here. Now we are ready to calculate the rate of change using this formula, but this one says calculate the rate of change from point 2 to point 1. I just demonstrated say on the previous page that it doesn't matter you go from point 2 to point 1 or point 1 to point 2, right? Either way is okay. Just make sure both sides are consistent. If you go from 2 to 1, the bottom one also goes from 2 to 1. If you go from 1 to 2 on the top, you need to go from 1 to 2 on the bottom also. As long as you do that, you'll have no problem, okay? I'm going to just, for convenience, use the top number minus bottom number. So this is between these 2 points, point 1 and point 2. So 136 subtract 97 over 0 minus 6. So let's do the calculation using calculator. 136 minus 97 divided by 0 minus 6. So everything is right. Negative 6.5. Negative 6.5. So negative slope means this line going down actually. But let's continue to calculate the next one. Next one is a rate of change, actually the slope between 0.3 and 0.2. So between these two numbers. So we just repeat this whole process one more time. And there's a read through here. 97 minus 71. And this is 6 minus 10. Let's do the calculation again. 7 minus 71 divided by 6 minus 10. Still negative 6.5. And the third one is between 0.4 and 0.3. I didn't copy this 0.4, so we cannot calculate this. Actually, this is still negative 6.5. Now, if you look at this rate of change, which represents slope, they're all the same. What graph has the same slope? That means slope never change. Only a straight line has a constant slope. As soon as you change direction, you have curve, the slope are not going to keep constant. So from here, these numbers, the rate of change being constant, we can tell this is a straight line. This data is from a linear model. Now, next calculation they want us to do is the ratio of rates. You already got this rates, they just want to do some ratios. So the first ratio is between rate 2 to rate 1. Make sure you do this in the correct direction. It goes from 2 to 1. This is 2. This is 1, rate 1. Even though they're the same, makes no difference this time, but they are not always the same. So make sure your order is right. So we get 1. So certainly this also get 1. Now, next topic, also the last topic for this video. How to tell if you have linear or exponential by looking at the rate of change and the ratio of rate of change. In other words, by looking at this data you calculated, how do you tell it is a linear model or it is an exponential model? Linear model representing a graph of straight line they have to have the same slope, right? Because otherwise change direction. That's how you identify here. As long as these numbers are the same, you get a linear model. If they are not the same, that doesn't mean it's automatically going to be a exponential model, because beyond linear exponential, there are many other models actually. We only cover linear and exponential model in this course, but there are many other models. So if they are not equal, how do you tell if you have a exponential model? You look at the ratio of rates. For exponential model, you look at the ratio of rates. And these numbers, this last column, ratio of rates, has to be a constant number, but not equal to 1. That means other constant numbers can be any number, but not 1. Apparently 1 representing this one the same. If this rates are the same, that means you get a straight line, it's not exponential. It still will be a constant number, it's just not 1. Again, being constant number is because that percentage increase or decrease is constant number, is a result of that. And look at the next page. Basically, this is an exercise to ask you, is this linear? Is this exponential? Something in the neighborhood. I didn't read the question actually. So they already give us this rate of change from 0.1 to 0.2, 7.0, 0.3 to 0.2, 7.0, they all 7.0. Guess what? They have same rate of change. And rate of change is the slope, same slope, that's the indication of a straight line. So we know this is a straight line, first of all. Secondly, if they ask you, is this increasing or decreasing? Positive slope, no matter they are equal or not, always indicate increasing. So positive slope, let's say rate of change. Increase, regardless they are the same or not, okay? And as long as it's positive, if negative, apparently it's decreasing. And a constant rate of change indicator is a linear. So this is the line, increasing line. It's positive at the same time, they're the same. So it is a increasing line. And that's all for this video. See you guys in the next one.